Hello everyone. In this video, we are solving the third problem from INMO 2024. So it says that let P be a odd prime and A, B, C be integers so that the integers this and this are all divisible by P. And so we need to prove that P divides each of A, B and C. So as most of you would have guessed, this involves divisibility and modular arithmetic. So let's begin with the problem straight away. So first I will begin with a claim. This is an easy claim. I don't think it's very hard to prove that if P divides A, then P divides B and P divides C, and symmetric, which means that if P divides B, then we can say the same thing about A and C. Okay, and same for C. So this proof is not very hard. So suppose P divides A, which implies that P divides A to the power 2023, which implies that P divides B to the power 2023, because of course it divides their sum. This implies that P divides P because P is a prime. And similarly, we can just repeat the steps and we can say that P divides C also. This is not very hard to prove, as you can see, so I will not spend much time here with the technical details. Now let's begin with the fun part. So we are given that P divides A to the power 2023 plus B to the power 2023. So now I will use modular arithmetic terminology. So A to the power 2023 is congruent to minus B to the power 2023 mod P. And from the subsequent steps, I will stop writing mod p, and we can square both sides to say that a to the power 4046 is congruent to b to the power 4046 mod p. Now what you can do is you can say the same thing about b and c. So b to the power 4048 is congruent to c to the power 4048. Okay, now we will use the first step here. We will use the first step here to draw some conclusions. So from the first step, we can obtain, what we can do is we can raise both of them to 4048, and we can say that a to the power 4046 times 4048 is congruent to b to the power 4046 times 4048, which is of course congruent to c to the power 4046 times 4048. So this is obtained basically by raising the second power to the power 4046 and comparing modular terms. And now from this we also know that a to the power 4050 is congruent to c to the power 4050 by the same step as done above. So from these two, let's try to see something. Notice that 4046 times 4048 is congruent to minus 4 times minus 2, which is congruent to 8, and this is of course mod 4050. Okay, now this means we can write 4046 times 4048 to be some 4050k plus 8, and we will use that in the previous steps. What we can do is this implies that a to the power 4050k plus 8 is congruent to c to the power 4050k plus 8, and we also know that a to the power 4050k is congruent to c to the power 4050k. And from these two steps, what you can do is you can replace a to the power 4050k. In this step, what you can do from the second step, it follows that c to the power 4050k is congruent to a to the power 4050k times c to the power 8. Okay, now what we can do, if p does not divide a, of course if p divides a, then we are directly done by the problem. So if p does not divide a, what we can do is we can cut a to the power 4050k both sides, and we are left with a to the power 8 is congruent to c to the power 8. Now the next thing we will do is we will notice that a divides 2024, and thus we can conclude that a to the power 2024 is congruent to c to the power 2024. So this is what we are getting, and we will multiply a both sides to get a to the power 2025 is congruent to a c to the power 2024, and a to the power 2025 is congruent to minus c to the power 2025 by the problem condition. And now again Using the fact that P does not divide C, we can cut off C both sides. So we are left with, using the first and third equality, we are getting that A is congruent to minus C, which implies that P divides A plus C. Okay, this is what we are getting. So A is congruent to minus C, and raising both of them to the 2023rd power, we are getting A to the power 2023 is congruent to minus C to the power 2023. And this is, of course, A to the power 2023 is congruent to minus B to the power 2023. And so now we are left with B to the power 2023 is congruent to C to the power 2023. Now we'll multiply B both sides. So B into B to the power 2023, this will become B to the power 2024. And this is congruent to B times C to the power 2023. And this becomes B to the power 2024 is, of course, congruent to minus C to the power 2024. This is fairly simple because B to the power 2024 plus C to the power 2024 is divisible by P. So from these two steps, what we can do is we can cut C to the power 2023, and we are left with B is congruent to minus C mod P. Okay. So now we also know that A is congruent to minus C, and from this too we can conclude that A is congruent to B mod P. Now to conclude the problem, what you can do is you can notice that P divides A to the power 2023 plus B to the power 2023, and from this we can conclude that P divides twice of A to the power 2023. This is because B to the power 2023 is congruent to A to the power 2023, and because P is not equal to 2, this implies that P divides A to the power 2023, and from this we can conclude that P divides A because P is a prime. P divides A, this is because P is prime, and we have proved that P divides A, and from this we can of course conclude that P divides B and C, as I had shown in the claim earlier. So this concludes the proof, and thank you for watching the video.